Example 2, section 2.5, using sine or cosine to determine the length of the hypotenuse. So we found one of the sides, now we find the hypotenuse. Determine the length of JK to the nearest tenth of a centimeter. JK on our triangle. This side here, which I'm going to call, let's call X, just for fun, because we never use X, right? Let's call it X. So there's part of my triangle. I need to label my triangle. If this is the angle we're talking about, this side is my hypotenuse. It's the longest side. It's opposite to the right angle. This side is my opposite side. It is opposite to the angle we're talking about. This is my adjacent side. It is beside the angle that we're talking about. I go to my acronym, SOHCAHTOA. And I think to myself, what trig ratio relates an angle, an opposite side, and a hypotenuse? Well, that's going to be sine again. Remember, all these calculations are exactly the same. The only thing that changes is which variables or which sides I use off my triangle and the trig function. So I start with my formula. Sine of an angle is equal to opposite over hypotenuse. I fill in what I know. I know that the sine of, what was the angle? Sine of 65 degrees is equal to my opposite side, which was 7.6, over my hypotenuse, which I called X. And then mathematically, to get this X by itself, I can't have it in the denominator of a fraction. So I first have to multiply by X on this side, multiply by X on this side. These will cancel over here. That will leave me with X times the sine of 65 is equal to 7.6. I still need this X by itself. So I'm going to divide by sine of 65. Because I divide this, these will cancel, but because I divided on one side of the equal sign, I have to divide it on the other side of the equal sign. So now I'm left with X is equal to 7.6 times the sine of 65, which is equal to, punch that in your head, oh no, not times, not times, not times. This is 7.6 divided by the sine of 65. Sorry to confuse you there a little bit. And then when I punch that into my handy dandy calculator, I get 8.385672, or because it tells me to the nearest tenth of a centimeter, 8.4 centimeters. There's example 2. And then example 3 is no different, except for the fact they make it a little bit more complicated by, hey, let's put this in a word problem. So your first step, draw a triangle, put your labels in, what it looks like, and then go from there. And I'll be right back with example 3.